Well, let's remember the motivation. All we're trying to do is use this information that we have to figure out whether we're surprised by our data if actually the groups all have the same mean. And any quantity we can come up with that combines all the information we have here could possibly serve that purpose. It's very possible that a quantity you can come up with would better reflect how well the data is surprising or not surprising under the null hypothesis than the official convention that people have come up with. However, the convention that I'm about to show you for combining this information to come up with a test statistic happens to have a reference distribution that has a certain name in statistics. It's a parametric method. It's a parametric test. And so what we're going to do is we're going to label the next column F, because the F statistic is equal to MSB divided by MSW. What did we do? We took sum of squared between and divided it by its degrees of freedom. We took sum of squared within and divided by its degrees of freedom. And then we took those two ratios and took their ratio. And that's the F statistic. So let's think about this quantity for a second here. If the sum of squares between divided by its degrees of freedom is way bigger than the sum of squares within divided by its degrees of freedom, what that tells us is that the groups are really far apart from each other relative to how much variation there is in each group. If the groups are really far apart from each other relative to how much variation we have in each group, then perhaps that's really surprising under the null hypothesis that all the groups should have the same mean. If this quantity F is really big, we have reason to doubt that null hypothesis. On the other hand, if the sum of squares between divided by its degrees of freedom is really small relative to the sum of squares within divided by its degrees of freedom, what that tells us is that the group means are pretty close together and there's a lot of variation in each group. And that tells us that perhaps our data set is consistent with the null hypothesis that the group means in the populations are actually identical. So we're going to compare this F statistic to its reference distribution. And if we think about repeatedly sampling from each of the different populations, for every set of samples from these different populations, if the null hypothesis is true, we could calculate this test statistic. If you imagine sampling from those populations 1,000 times, where the null is true, we get 1,000 different values of this F statistic. And if we made a histogram of those, it might look something like this. And it would actually look something like this. It would have this general shape. The idea is that we know mathematically what this histogram would look like if we were to simulate. In other words, when the null hypothesis is true and the means are the same in each group, we know mathematically what values we'd expect to see for the F statistic. So then what we do is we take the value of the F statistic that we actually observe, and we look at the proportion of the time, the probability that we'd see a value of the F statistic at least as large as that. So the next column I'm going to label here is going to be the p-value. What's the p-value? It's the probability that we would see an F statistic at least as big as what we actually observed given that the null hypothesis is true. When you look at your ANOVA output in some software, this is just going to be a number. This will be like 0.3. Maybe that's your p-value, for example. This picture here is not part of the ANOVA output. This is just a picture I drew right here. But it's important to visualize this reference distribution when you're thinking about your ANOVA output, because all your ANOVA output is doing is organizing your information so you can see where the test statistic comes from, so that you can see your p-value. You can see how surprised you are by the amount of variation between groups relative to the amount of variation within each group.